wants to see what we get. Okay, so number 2, well, the general directions are find the volume of the solid obtained by rotating about the specified axis. So, what's the information from number 2? We have y equals 1 minus x squared, and y equals 0. And we want to rotate this about the x-axis. I don't know any decent way to do one of these things without drawing a picture. So let's draw a picture. This is obviously upside down parabola. Crosses the y-axis at 1, moves down. Y equals 0 is that what it says to me? I had to do these last night, and it seems very unfamiliar. Is that right? And they want you to spin this around. So this is a parabola. They want you to spin it around the x-axis here. Oh, maybe it is familiar.
So it's only the top part, and then spin that around?
Yeah,
Okay.
but it doesn't really matter if you think about it. If you just kind of take this thing and spin it around, or if you take the whole thing and spin it around, you know, it's a football, right? Sort of football-y shape. Okay, so what we want to know is the area function, right? We're going to integrate over the area function. And it looks like we're going to integrate along the x-axis from -1 to 1. So really the key here is what is this area of this circle here? So if this is x, well, what we want is the y, right? For this function here. So that means the area is going to be pi r squared or pi y squared, since y is the radius of that circle. We have y in terms of x, so we know this is going to be pi times 1 minus x squared squared. So that allows us to do this. I'm going to take the pi outside and get 1 minus 2x squared plus x to the 4th. And from there, it should be fairly straightforward. X minus 2/3 x cubed plus x to the 5th over 5 from -1 to 1. You could have skipped a step here if you see this is even and you just take 2 out. I'm not really with it right now. So this is 1. That's going to be a minus plus 2/3. And then -1/5. And then here we're going to have minus the opposite of that, -1. I have to look again. It's a -2/3. So this is just going to be the opposite, plus 2/3 minus 1/5. So it's plus minus minus. So it's 2 minus 4/3 plus 2/5 times pi, which I don't know what that turns out to be. 30/15 minus 20/15 plus 12. So 24/15 or 8/5. Does that sound right? I guess I should stop doing the integration part, since I think you all should be able to do that by now. Okay, other homework problem questions?
Number one.
You didn't notice that I had that on the board before the iteration.
Can you do 39?
I'm sorry?
39?
39, okay. We're going to do one first.
Okay.
All right. Okay, so number one, we get a little more information. We get y equals 2 minus a half x, y equals 0, x equals 1, and x equals 2. And you want to rotate this about the x-axis. So let's think about what this picture looks like. This is a straight line. It's got a y-intercept of 2 and a negative slope of -1/2, which sets it running through this point 0, 4, and then 4, 0, and here it's 0, 2. And then we have y equals 0. So that's going to be over here. And x equals 1. And x equals 2. So we have this trapezoid here. And we want to rotate it around the x-axis. So again, we want to find the area function here. The area with respect to x is going to be we're going to be integrating along x-axis, the area function, and the area, of course, is these are circles, so it's pi r squared. The trick is to figure out what r squared is. Well, apparently r squared is y of this function. So we have to look now. It's nice. We have y listed in terms of x. So pi times 2 minus a half x squared. And clearly we're integrating from 1 to 2. So we integrate 1 to 2. Take the pi outside. 2 minus 1/2 x squared is 4 minus 2x plus x squared over 4. And again, I think I'll let you handle that integration. That's pretty straightforward. Okay. 39, it's a big number. It's probably not one of the easier ones. I didn't do this one last night. So I'll have to think hard. The base of S. What's S? S is the thing we want the volume of. It's an elliptical region with a boundary curve 9x squared plus 4x squared equals 36. So, yeah, I want to erase this. Is that okay? Quick quick little refresher here. My next squared. Equals what? 36. So when you have an ellipse, well, maybe we don't know that yet, but the right way, the right form you want to put this in is so the x squared over 4, which is 2 squared, plus y squared over 9, which is 3 squared equals 1. Or sometimes you'll write this as x squared over a squared plus y squared over b squared is 1. A and b being the semi-minor and major axis. Since y is 3, y is the major axis. So we know the ellipse goes through plus 3, minus 3. And this is 2, so it's going to go through 2 on the x-axis, I mean on the y-axis, and minus 2. So that's our elliptical base. Everybody happy here with ellipses? Ellipses were fun. Cross sections perpendicular to the x-axis. Perpendicular to the x-axis. That. So that's the base. I don't want to draw it because I'm going to draw it like that. Sure helps, like, if you're artistically inclined when you're trying to draw these things, but I'm not. I just see a bunch of lines. Okay, so this is the base. Clearly, we want to integrate along the x-axis from -2 to 2, the area function. And the area is an isosceles triangle. So the question is, what value, should we use the base or the half base? I guess we could use, I guess we might be better off using just like the half base. So how do we get this value here, the y? Well, we take our equation, let's solve for y. So that's y equals, I'm just trying to do this backwards in my head, 36 minus 9x squared over 4. Or if you like, 2 outside the. So that's this distance here. We could have done minus, and it would have been 1 down here, but it doesn't really make any difference. So that's half the base, right? Let's just figure this out. If this is, let's call this.
Wait, why'd you divide by 2 instead of 4? Sorry.
Well, I divided by 4, but that was before I found the square root. So I took,
Oh, okay.
in other words,
Yeah.
kind of like that.
Okay.
So let's, I don't know, we call this P, and this is 2P, and this is the square root of 3 times p. And so the area of this triangle, the area of this triangle is 1/2 the base, which is 2p. 2 times the square root of 3p over 2. Right, so it's nice, that's just the square root of 3p. That's the area of the triangle. This is p, right? Is that it? Square root of 3 times 36 minus 9x squared.
Can you simplify that to 6 minus 3x? Or,
We got a 3 in here, right? So that's 3 square root of 3 times 4 minus x squared. Okay, so that's the integral. Oh, it's even, so let's just say from 0 to 2. That's not a surprise, is it? You know, the volume from here to here and the volume from here to here are the same. So 2 times square root of 3 times 3 is 6 square root of 3 integral square root of 4 minus x squared dx. Okay. Now, that should be the hard part, right? Anyone have trouble with this integral? Should have trouble with that integral. We didn't really do anything quite like it. There are 2 ways to go about it. Well, I didn't bring my. I don't have that thing in the back of the book anymore. Does anyone want to look it up for me? See what they say about it. Wait a minute, is that just a trig substitution?
Yeah, it can be.
Let's try.
Looks like sine.
So we say x equals sine of u. So dx equals cosine of u. No, that's not going to work.
It's r sine u. R sine u.
Well, yeah, but it's 2, right? But that's still not going to work. Oh, no, it is going to work. I'm sorry.
No, you forgot.
I was thinking this is another problem that they gave where you couldn't really figure it out. All right, so, okay, square root of 4 minus 4 sine squared times 2 cosine u du. So that becomes, take 2 out of here and 2 out of here, and that's cosine squared cosine. Oh. Yeah, that was on the exam, wasn't it?
Yeah.
Okay, so that's for cosine 2u plus 1 over 2 u, or for sine 2u over 4 plus u over 2, which is sine 2u, which is what u is here. Oh. Oh, probably won't, what I probably want to do, well, all right, let's get rid of that, we'll put 2 here. Sine of 2u is 2 sine u cosine u plus, oh, this is what I want, plus 2u. So I still have to figure out what u is here, so u is the inverse sine of x over 2. So 2 times, this is x over 2. This is the square root of 1 minus x squared over 4 plus 2 times the inverse sine of x over 2. And now we can evaluate this between 0 and 2. Shall I continue, or are we okay?
Can you evaluate it?
I'm sorry? Can I evaluate that?
Yeah.
Okay. So you can't do this with pencil and paper, but you can with a
Because I
marker.
feel like we would get a decimal and then the answer is a whole number.
I'm sorry?
But-
Oh, nothing. Never mind.
Okay, so if I plug in 2 here, I get 2 times the square root of 1 minus 4 over 4, 0, plus 2 sine inverse of 1. And that goes away. Minus 0 times the square root of who cares? That's another 0. Minus 2 sine inverse of 0. So that's 0. That's 0. And that's 2 times the inverse sine of 1 is pi over 2. Just pi.
And then you multiply by 2.
Oh, did I forget to do that? I thought I had that in there.
Because you did 1/2 of it, the area of 1/2 of it, you have to do the other half.
Oh, that's right. There was kind of double symmetry, right? I mean, there's like this side and this side, and there's the bottom and the top. So yeah, you're right. I left out a factor of 2. Thank you. I don't know how to put it all the way through.
Do you have to
Two.
multiply it by 6 root of 3 or do we do that already?
I'm sorry. Please speak a little louder.
The 6 root of 3?
6.
Lower left,
Lower left.
what happened to it?
Oh,
Oh, I left it out. Maybe that's where that 2 is supposed to come from. Hold on. Okay, so if I multiply this by
6 root 3.
times 6 root of 3, would that be the answer?
Oh, the answer is 24.
Eh.
Mistakes were made. I give you a choice. You can make me beat my head against it and I'll figure it out, or you can get practice if you like to do that. Find my error. You know.
Can we have a little extra time for the homework then?
Oh yeah, if you don't want to turn it in yet.
Okay, thank you.
Hasn't anybody noticed that I'm fine if you turn it in late? All right, anything else? Homework? Okay.
Oh, also, number 4.
I'm sorry,
Number 4?
on the
Yeah.
you're on the exam?
Oh, no, on the homework.
On the homework. Okay. You know, when I do these problems on the board, so what if I can do that? Sometimes I can't do it very well on command, but I think the important thing is not to pay attention. You can pay attention to the answer, that's of course. But what's my thought process? Now, the way I do it isn't the only way to do it. If you did it different and it works, that's great. If you don't really know how to go about it, you probably want to watch the details. And I think everyone should have noticed that the first thing I do is I write the problem down. I don't know why, even when I'm just duplicating something, it's written down, at least for me, the act of writing it helps. Okay, about the y-axis. And then you probably noticed I try and draw a picture, which, of course, you have a nice calculator. If you're not sure what the graph looks like, you can use that. Okay, so I have to remember what the log of x looks like. Well, I know at 1 it goes through 0, and then it gets negative and goes down. And it kind of rises forever slower and slower. That's the log of x. Y equals 1, right? So I want to use a different color here. And y equals 2. And again, you might want to think about, well, if y equals 2, what's this point? The log of x is 2. What's x? It's e squared, right? Oh, I'm sorry, that's 1. It's e. This is 2. So this is it's e squared 2, e1. Okay, and then also x equals 0. So I guess here. All right, so this is the area that we're talking about. But we want to rotate it around the y-axis. So again, we're going to have a circle, which is the area, and the radius here is the x coordinate, right? So we want to integrate from 1 to 2. Again, pi r squared, r is x. Oh, which way are we integrating? We're integrating dy, right? Here's my area function. So we don't want it in terms of x, we want it in terms of y. So we have to take that, y equals log of x and turn it on its head. Right? X is e to the y. So this becomes pi e to the y squared, or pi e to 2y. And that's my area function. Should I go on with this?
I'm good.
Should I evaluate this?
No, I'm good.
Okay. Okay. I don't know why, I feel like I need a break already. For the benefit of everybody who might not have been here 10 minutes ago, I'm going to repeat something I said, which is that I don't think today should be particularly hard. We're going to learn 2 things. We're going to do 2 chapters. Goes right by, but I don't think they're very hard. The following chapter, I'm not even sure what I'm going to do. Physics. I don't really I love physics, but this isn't physics, this is a science class, it's a math class. So I'll see if there's something in there that I think is mathematically a good thing to spend time on. But then the next chapter is on differential equations. And I suspect that will be a little harder than what we've done. So I suspect you want to keep on your toes for the next week or 2 or 3 before we round up and, take a final. Okay. So, you clear the board, Catherine?
Yeah, that's
So the book calls these things applications. It's a technique. It's a nice little technique. We're going to build a little on what we've done, just a little tiny bit. So the first topic is arc length. Or length of a function. You have some function. And we're not interested in the area under it. We're interested in how long is it. So you could think of us breaking it down into little intervals. And kind of trying to add up the lengths, right? And then maybe it kind of jumps around, and we have to use smaller and smaller points to estimate the length. Suppose we have this curve as a parametric equation. So we have x as a function of t, and y as a function of t. You could think of that as the x and y coordinate, like something's moving, and t could be like time, like over time it moves. So what are these points? Well, there's a starting point, which let's just call that x0, y0, and another point, x1, y1, all the way out to x to the n, y to the n, which is our B point. We're going to go from, say, A to somewhere out here, D. We want the length. So, we know, given x and y points, let's call delta x sub I the difference between x sub I plus 1 and x sub I. Delta y sub I is the difference between y sub I plus 1 minus y sub I. Now I'm just breaking out the x differences and the y differences between succeeding points. And then the Pythagorean theorem tells us that, the length between I and I plus 1 is just delta x sub I squared, square root of delta x sub I squared plus delta y sub I squared. Okay, Pythagorean theorem, right? Or distance formula, if you like, between 2 points. So now, we're heading towards a formula here, and we want you to note that the derivative of f of t at f, which is the x-coordinate, with respect to t is approximately equal to, I guess I'm gonna do kind of a exploded view here. Well, there's no t here, is there, right? But there is an x, a delta x. And this derivative is approximately that delta x over the change in t over that period. And likewise, I better write that in. Nobody said anything. No, I meant to write a g there. G prime of t is just the change in y over that, if you like, time interval. So we could express delta x as delta t times the derivative, and delta y as delta t times the derivative, approximately. So if we're going to sum all of these guys, the length, right, that's just going to be a summation delta x's, right, which we're going to express now as delta t prime of t squared, and the distance formula, or the Pythagorean theorem, delta t g of t prime squared. And we're just going to sum this over all these points. Well, that would be great if we wanted to trapezoidal rule or Simpson's rule, but we don't really want to do that. What we want to do is we want to increase the number of points, letting the distance between them, the delta t, go to 0, and that gives us, this is the length, right, approximately. By letting this go to 0, we get the exact length as this integral from a to b of derivative of t squared, square root of prime of t squared dt. So this is our distance formula, our length formula for some function given by these parametric equations. Right, let's do an example. Say I have a function x equals t and y equals t squared. And this is a curve. We're going to look at it from the point 1, 1 to 4, 8. So as x and y go from 1, 1 to 4, 8, t varies on what interval? Well, really t equals 1. Sorry. I have written something down wrong. must have the problem have been?
T squared over 2? No,
No.
it's 416. Instead of 8, it's 16.
Anyway. Sorry.
I think the H should be 16.
Okay, that better? So this goes from 1 to 2. Okay? So if this is f of t, f prime of t is just 2t, and if this is g of t, g prime of t is just 3t squared. Plugging into our formula, this is just integral from 1 to 2, square root of 2t squared plus t squared, 3t squared squared. Well, see a factor of t squared in there I can take out. That's a t. We have 4 plus 9t squared et. All right, that's not too hard. That's just, we can do that with a substitution. We could just say u equals 4 plus 9t squared. So du equals 18t. That would make it convenient to rewrite this as 1 over 18 times 18t square root of 4 plus 9t squared et, because then I just get 1 over 18. I'm not going to switch the u here, I'm just going to say square root of u du is 1 over 18, u to the 1/2, so u to the 3/2 over 3/2. For 1 over 18, 4 plus 9t squared to the 3/2. From, what did I say, 8 here? Oh, 1 to 4. No, 1 to 2 t. So this is just this integral. Okay, this is the length. The length formula. Now, there is before we try one of these, before you will try one of these, there's a simplification you should know about. What if instead of what if instead of x and y being a function of t, we just have y equals some function of x? Well, you could kind of think of it this way. You could say, well, it's f of t, x equals t. Well, since t is x, I don't have to do it. hide it. So f prime of x is just, my derivative with respect to y. But with g, my g prime of x just becomes 1. So if all I have is something like this, my length formula gets a little simpler. So again, integral from a to b, square root. But now we can just integrate, we can just differentiate with respect to x here. And g prime t or x is just 1. So now our formula is a little simpler. Okay. Let's just do one of those. And then you can have some fun with this. Say we have a parabola, sideways parabola, y squared equals x. And we want the length from 0, 0 to 1, 1. Well, here we're just going to switch the roles of x and y. So we're going to have x equals y squared. This is now my f, right? So the derivative of f of y is going to be 2y. And I don't have a t, so I g prime of y is just 1. And my formula tells me this is just the integral from 0 to 1 of this squared, square root of this squared, y squared, plus 1 dy. Ah, this is the problem where they want you to look it up in a table. You can do a substitution here, but what you have to substitute is a hyperbolic, which we don't really want. We're not going to mess with that. So the formula from the table in the back of the book is integral of a squared plus u squared du equals u over 2 square root of a squared plus u plus a squared over 2 log of u plus square root of a squared plus u squared squares plus c. So taking a look at my function there, I guess what I want to do is take out a factor of 2, right? So this becomes 2, 0 to 1, square root plus a quarter. So now, this kind of looks like this if you set a equals 1/2. So this says that is 1/4 square root of y squared plus a quarter. That's a squared. Wait a minute. Hold on. 1/8 log of y plus square root of y squared plus 1/4. And we want to evaluate that, well, we want to multiply it by 2, right? And we want to evaluate it from 0 to 1. So what does that give us? 2 times 1/2 square root of 1 plus a quarter plus 1/8 log of 1 plus, again, square root of 1 plus a quarter minus, okay, well, this is 0, plus 1/8 log of square root of a quarter is 1/2. So what do we get here? We're going to multiply through by 2. And we have the square root of 5 over 2 plus a quarter log of 1 plus square root of 5 over 2 minus a quarter log of 1/2. Okay, we can simplify that a little. It's basically it's kind of a mess. Okay, any questions about this length formula? Because I would like you to all try a couple of problems.
Just the first 2.
Can we take a break now?
Thank you. Why don't you all take a break? Kind of overdue, aren't we? We're all right. Diana, I think I'm going to run down, see if I can't find it in the math office. That's so weird. Sure. Put down there.
Which page is this? How'd you get it? How'd you get the number?
That's the other, the non-Foothill. It's basically, it's like the same author.
Oh, I see what you're doing. Oh, it's getting harder.
This?
Or maybe I'm just not paying attention.
Yeah, no, that's it. I'm so, I don't know.
Let's see more.
A little bit weird.
Okay, well, there's like other stuff boots. I don't know.
True.
The boots are so messed up. They're coming off. And we sold them like 3 times already.
Maybe you should make this.
No, these are expensive. I got it on the present. send me around the chocolates.
I'm trying to.
Not till I break. I'll wait for another present to come. Drop the hand. Okay, so my feet hurt so much. Yeah, my shoe's breaking.
Do you want me to order for this?
I would, dude, by the time they deliver it, we'll be done. Yeah. And I use DoorDash. Well, my friend uses DoorDash because, yeah, I did like one delivery and I got tipped so little that it wasn't even worth it because my gas for my car. Dude, it costs like $60 a fill, $70 a fill gas. No way.
Well, okay, one of my work there as a designer. And he says that it's
Like the app design, you know, no offense, the apps kind of suck.
oh, the app. I don't know if you work on the app. It's doing the website. Oh, I don't know what the website is like. Maybe that's why he's hired. It's not
What? No, that's not what I'm saying. I meant like,
stop looking so shitty. But he's like an intern. That's why.
oh wow, so crazy.
First delivery is $1.
What?
First delivery is $1.
Yeah. Dude, they charge way too much delivery charge. If you work there, then you get it for free. But then they deliver a lot of stuff that other people will deliver.
Wait, what? Like what?
Like ice.
What about Chipotle?
What?
What about Chipotle?
I don't know, dude, what the heck?
What?
Oh, well, my friend lives next to Chipotle, so I just go like, I live next to Chipotle too, so. Because I don't really like Chipotle.
You don't like Chipotle?
Yeah, I really don't like Chipotle. It's expensive too, for like,
Wait, yeah, it's like $6.
no,
Yeah.
like a burrito, it's like $7, $8.
No, and you can put like guac in it.
But you need it with guac.
Mm.
But you need.
You can get $8 burrito.
I go to a legit like Mexican place.
No, Chipotle's legit.
No, that's not. People from McDonald's do that.
But what?
You see people from McDonald's, it's not legit.
It did.
Yes, they sold it.
If you're ready, you want to come in and work on those two problems. Not there, so probably at my home. I will find out tonight and I will email you and let you know. erase this. Anyone finish number one?
Yeah.
You come out with a really nice looking number.
Mm-hmm.
Isn't that sweet when that happens?
Yep.
Okay. Does anyone feel like they would still like more time on these two? Should I take that as a no? Would anyone like to do number one on the board?
All right. Whatever. Not gonna do the other ones. Screw it.
Alright, I'm gonna let me erase this. We can have these two boards. How about that? I'm thinking about doing number two, which is also has a nice, comes out nice. looks like the answer.
Yeah, and to check, you try to see if it's around. Well, you take the distance between A and B, and then you try to see.
I see, yeah, that's a good check. I mean, that's kind of a good sanity check, right?
Mhm.
It should be, the distance between the points should be less, but in the ballpark.
Yeah, it should be greater than the straight line by less than, if you go along the x-axis and the y-axis.
Oh, yeah, that, okay. You should put bounds on it, yeah, that way.
Yeah, it's pretty close to the straight line now,
Yeah.
for whatever reason.
For DU, did you mean just 9/4?
Yeah.
Is this, I was just wondering if this was just an approximation or is this the actual?
No, that's the exact value.
Okay.
Calculator, son. Well, I'm not really sure.
Well, I was just surprised because I did it a little differently, but in my last, before I was about to give up, I get this. And I said, oh, this has nothing to do with calculus, it's just number magic. And I thought, all right, let's do that. What's 44 times 9? I'm too tired to do that in my head. 396 plus 4. Oh, that's 400 over 9. Well, the square root of that is 20 over 3. That cubed is 8,000 over 27. And here, it's like the square root is 2/3. So cubed is 8/27. So that's 7,992 over 27. What are the chances that that divides out evenly? Probably some reason for it. Okay. Doesn't someone want to have fun? Number 2.
I'll do it.
Oh, good. Okay. You're sure?
I think so.
You want some help from somebody?
Number 2.
Well, it's so much fun. I don't really want to give it to just one person. All right, you can have it.
I mean,
Go for it. Go for it. Go for it. If you got it, then you know I think it's fun.
well, see, no, I'm not sure anymore.
Uh-oh.
Wait, I see why it's fun.
Oh, that wasn't my goal.
That's fun.
Reverse psychology.
Psychology.
That's good.
This is when it's fun.
I guess I should say fun with algebra and trig. Isn't that nice? Anybody who didn't like finish that, just take it home and do it. It's fun. There are people who do create problems who have kindness in their heart. Right. Okay, any other questions about this length formula? There's some practice for it in the homework tonight. Okay. We ready? Catherine, you done?
Almost done. But you can erase that and get the rest.
This part? Maybe I've been around math too long, but I just found that really satisfying. Okay, the next topic, which we're going to cover, is finding the average value of a function. So, before we just dive right into it, imagine you're a scientist and you're measuring, I don't know, global warming or something. And you take a temperature reading at, I guess, midnight. I guess midnight would be a little colder, and then 1, and then 2, and then 3, and then 4, and 5, so forth, up till midnight again. And so you'd have a bunch of temperatures. Is from 0 to 23. Do them on the hour. So how would you find the average temperature during the day?
You would take the average of all the numbers.
Yeah, how do you do that? I'm asking a dumb question.
Add all the data points.
Yeah, you just add them up. And then what?
Divide by 23. Right, 24.
Yeah. That's a discrete average. Well, what if instead of just hourly, you actually have a recording device? So here's your temperature. Well, you could find this area, right? If you know how to find that area as an integral. But what is that area? What are the units on that area?
Temperature times time.
Time. Yeah. Yeah, but we want the average.
Divide about the time.
So, yeah, we would just divide out by, in this case, it's 24 hours again. So that's essentially what you do to find the average value of a function. You integrate from your starting point to your end point, that function. But then you want to divide by that x distance. In this case, it was the time distance. Now,
Billy days.
in some sense, that tells you some point that represents kind of the middle, right, of the temperature. It doesn't tell you the high or the low, it tells you kind of that number in the middle. Now, assume for a second that this function is continuous, doesn't have any jumps. Question is there some place along here where this average occurs?
Yes.
You would think so. You would think so. There's a very important theorem in analysis. It's called the mean value theorem.
For integrals.
And I'm going to do kind of it's not a real proof. It's kind of a hand-waving proof. So it goes like this. So I have that average value, right? So that average value has to be less than or equal to the max, right? The average can't be greater than the maximum, right? Somewhere along here there's a maximum, right? It also has to be greater than or equal to the minimum. This function also has to have a minimum, right? So somewhere on here is a maximum and somewhere is a minimum, but it's continuous. So there's an interval from the maximum to the minimum that covers every value in between the maximum and the minimum. So it has to hit this value. That's very sketchy proof.
Well, for this it would be the maximum volume and the minimum volume.
No. I'm talking about the function, not the area. I'm saying this function, like in my diagram, maybe this is like the minimum, and maybe over here is the maximum, right? The average has to be a value between these. And since this interval from here to here covers every possible value between those two, it has to hit that average. So what the mean value theorem tells us is this for f continuous on the interval a to b, it says there must exist a c such that f of c equals the average. I mean, in practice, it's not that difficult to find that value if you have a function. Okay, let's try a problem. So let's take the function 1 plus x squared, and let's look at it on the interval -1 to 2. So let's take a look at what does that look like. That's kind of like this. So -1 to 2. So the formula tells us the average value is equal to b minus a, that's 2 minus -1, or 3, times the integral from -1 to 2 of 1 plus x squared. So we're taking this area and dividing it by this length here. Okay, that's pretty easy. This is x plus x cubed over 3, -1 to 2, and this is 1/3. That's 1/3, 2 plus 8/3 minus -1 minus 1/3. So we're just going to add all these. So it's 3 plus 9/3, which is 12, over 3, which is 4. Well, let's just think about that for a second. We know here the minimum is 1, and we know here 2, the maximum is 9. So, 4 sounds like it's a pretty good guess for the average. Okay, so let's take it a step further. There must be a C such that f of c equals 4. Well, that's not hard. 1 plus x squared equals 4. So x squared equals 3. So clearly x is the square root of 3.
Wait, I think instead of 4, it should be 6.
It's possible. Oh, you think 3
Should be 2.
plus 3 is 6. Let me try that again. 3, 9/3 is 3 is 6, divided by 3 is 2.
Yeah.
Oh, that changes everything. 2. Okay. No, that's a 2. That's a 1. So that's a 1. So, okay, so that really wouldn't have made much sense. Well, that could have. So at 1, that's where the average value is. Okay, that's average value of a function. Mean value theorem says that for a continuous function, at least, the average has to be able, there is an x for which the function achieves that value. And on the other side of your sheet, you've got a couple problems you could try. They're pretty easy. So, please give that a whirl. Anyone still working on these? No? Okay. I'm just going to ask this in a funny way. Does anybody think they might want to go into teaching?
I want
And
to
would
do
like some
educational.
experience up in front of the class?
I want to do educational technology.
I'm sorry?
I want to work on educational technology.
Well, that's not being a teacher though, right?
No, I want to be a content creator for like Khan Academy.
It's a good idea. It's kind of hard, you have to make something and then you look at it and you go, would anyone else want to look at this? It's hard to separate yourself. Okay, somebody want to try number 3 on the board?
I'll do it.
Okay. These were pretty easy, weren't they? I think actually though, I think you wanted to, right? That's the antiderivatives, you want the integral side anymore?
Oh, yeah, no.
Uh-oh. I think you forgot to add 1 plus x.
Oh, yeah, wait a second.
That's great. Looks right to me.
Okay.
But I don't have a really good record today, so. Okay, everybody in accord with that? Did you find C?
Yes.
Oh, you're finding C, sorry. Okay, so you reach the average of square root of 8 over 3 at minus 1/9. Very good. Any questions? Someone want to see number 4?
I can do that. C gets a bit weird.
Hmm?
C gets a bit
It does. Okay. finding C may not be so easy, that's true.
Yeah, do I go to another board?
You can do whatever you want. You can erase, you can,
All right.
I think actually, it's not hard if you don't try too hard.
Yeah, I suppose. I did try hard because I was good at it.
Okay, so that's the average.
So, and then now for E to the C. So that's on both sides.
Okay, are there any questions about this? All right. So there's I think it's a pretty easy homework assignment where you'll do both of these, the length and the average value.
Is this?
But I saw the answer. Are you trying to make more out of it?
No, it's just this.
Okay. Well, thank you all. I'll be here for a few minutes if you have any questions.